these are the basics to understand the Ohm's law. And before defining the Ohm's law and Ohm's law and KVL and KCL, you have to know some basic definitions. I will share these things. Don't worry about the notes. Later you can write the separate notes about this. Before defining the, we are discussing all those things to state the Ohm's law, KCL and KVL. Let us discuss about the nodes, branches and loops. What is the basic definition? Before discussing about these things, I want to explain something here. Suppose if you take a house, there is a switchboard. So you can see so many switches on the switchboard like this. From the switchboard, you can find one phase wire and one neutral wire. And if you want to connect it to tubelight or fan, let us take a fan. Let us take a fan. So there are two wires are there to connect the supply. Now in this, one phase is connected to one wire and the neutral is connected to other wire. Once if you close the switch, what will happen here? Current I is flowing, and across the switchboard, how much voltage is there? 230 volts. Voltage V. And imagine the current I is flowing 10 amperes. How many amperes? That is immense 10 amperes, and this is 230 volts. And if you open the fan, you can see a copper wire which is wound like this, and which is having a property of what? Every material is property of resistance. I will come to the property of resistance, inductance, and capacitance. Resistance is the property of resistor, and I will discuss what is a resistor. And inductance is property of an inductor. Shravan, inpisundamma?
Yes, sir.
Okay, very good, very good. Sai Kumar, are you there? Capacitance is property of capacitor. And if you open the fan, you can find a copper wire which is used as a winding, so which is having a property of resistor. And inside you can see, and this is symbol for resistor. I will explain each and everything about the resistor. And inductors, there is a symbol for inductor and there is a capacitor. That means resistor, inductor and capacitor, these are the letters which are used to indicate this RLC. And where these are connected, this is an equivalent model of a fan, equivalent circuit. The total fan is modeled as a electric elements. What are those elements? RLC elements. We will discuss later. And where this fan is connected here, where the fan is connected on? Across the supply, voltage source. And if you actually it is AC, as we are discussing about the DC, how to define a DC here? Otherwise, E symbol se use cheddam. We have used this symbol, right? A longer line and shorter line. Let us take this is plus and minus 230 volts something. So this is the supply, and these are the wires. And these are the wire connections. These are the which connections? Wire connections. And this is an what? Equivalent circuit the device, the fan device is converted into electrical elements. What are those elements? RLC elements. Okay, that means this is known as a electrical circuit. Electric circuit. What is this? Electric circuit. So this is what the electrical circuit is, nothing but a practical situation. A practical situation. Suppose if you connect a heater to the same supply, heater is can be modeled as a resistance. This is R1, this is R. Okay. Suppose if any bulb is connected here, then it can be added as R3. So what is the, we can convert those appliances into inductor, capacitive and resistive elements. I will tell what is the RLC later. Finally, what I am trying to say is that any practical situation can be written as like this. Capacitor, inductor, and again a resistor. All the electrical appliances can be converted into like this. All are fed from the supply. So there is a voltage V, and once the switch is closed, current I is flowing through these elements. Now see here, let us see one by one here. This is called this is at this particular point, how many elements? These are called elements. R1, R2, R3, RLC are called elements. And voltage source is also an element. At this particular point, how many elements are connected? Please respond. One is R2 is connected. Another one is R3 is connected. R4, C and L are connected. I will explain about L and C later. For the time being, let us try to understand here. All these elements are also connected at this particular point, and this element is also connected at this point, and this element is also connected at this particular point. This particular point is known as a node. What is that? It is known as a node. And from here to here, there is a R2 resistance here, and here to here, this is known as a branch. What is this? This particular element is known as a branch in a circuit. And this also is a separate branch. Node and branch. This is the difference for the branch. And this total connections is an electrical circuit. Okay. And this is known as a loop. Loop means we are starting from here and all these elements are connected, and again it is a closed path. And try to remember this circuit. I will explain one by one, and then you can clearly understand here. Now come to the definition here. A branch. A branch represents a single element. A single element, only a single element, such as a voltage source or a resistor. It may be a voltage source or a resistor, which is known as a branch. So if you see this particular example, hope you are understanding here. This element, this is a voltage source, but in the circuit it is known as a what? Branch. Okay, and this R4 is also a branch. V is one branch. Next, R4 is another branch. Capacitor C is another branch, and L is also another branch. This R3 is another branch. R2 is another branch. How many branch elements are there? Each element is considered as a branch. These many branches are there. It is a branch. Next, what is another one? A node. A node is a point of connection between 2 more branches. Please,
log this one.
Meher, please mute yourself on 105. See here. I am writing this another circuit here. Plus and minus. There is a 10 volts. This is one resistor. Let us take R1, R2, and this is symbolic representation of a resistor. This is R3. Now, at this particular point here, this R1 is connected, R2 is connected, and R3 is connected. This is known as a node. A node is a point of interconnection between two or more branches. Okay. Now let us take this particular point. I can say it is a node? Please respond. Can I say it is a node? What is a node? Point of interconnection between two or more branches. Follow అవుతున్నారా? Pujita 145, 145.
Sure.
Can I say it is a node? So let us take it. This is a point B. Can I say this point B as a node? Why?
There is a connection between two nodes, two branches.
What is one branch? R1 is one branch. Okay, now other branch is what? What is other branch? Voltage source. Voltage source is another branch. Please. This is one branch. This is another branch. Otherwise, let me give. This is A, B, C, D, E, F. Ikkada branch enti? AB is one branch. And BC is another branch. This branch and this branch are connected at this particular point. Okay, na? So B is also one node. But only two elements are connected here. This node is known as a simple node. A node antarama? This is simple node antar. But at node, let us take this node 1. At node 1, how many elements are connected? The branch BA is connected, AD is connected. F element R3 is connected. AE is connected. How many branches are connected at node 1? How many are there? R1 is there, R2 is there, R3 is there. Greater than 2. And there are 3. So 3 elements are connected, or 3 branches are connected. So this is also a node, but this node is called a principal node. Principal node. What is the difference between? I will use these definitions later. Simple node means node is represented by n. If n equal to 2, the number of branches which are connected at a point is equal to 2, that node is known as a simple node. If n greater than 2, it may be a 3, or it may be a 4, or any. Suppose if another element is connected here, another resistive element is connected, then how many elements are there? 1, 2, 3, 4. 4 branches are connected here. It is also come under principal node. Greater than 2, number of branches which are connected at a particular node is greater than 2, it is known as a principal. So that is a node. Node is the point of connection between two or more branches. But what is a branch? A branch represents a single element. It may be a voltage source, current source, or a resistor. Okay, such as voltage source or a resistor is known as a branch. Now, what is a loop? Next definition is loop. A loop is any closed path in a circuit. A loop is any closed path in a circuit. Suppose R1 is the resistor 1, R2 is the another resistor 1, R3 is the another resistor, another R4 is there. Now what is a loop here? Any closed path. So let me give A, B, C, D, E, F. Can anybody tell me how many branches are here? Please respond. How many branches are here? 107. Shiva. Shiva is not responding. Giri Prasad, 110. Nineteen 108. Sri Varsha.
Yes, sir.
Yeah, please. Can you tell me how many branches are there, Amma? A, F is one branch, and a voltage source is a branch, and one branch. Can I say R1 is a branch?
Yes, sir.
So second branch. Next, what about this R3?
R3 is
This
also branch.
R2 and R4. So how many? You can't say this is a branch because A between E and D, is there any element?
No, sir.
No element. You can't say it is a branch. So finally, please tell me how many branches are there? Branch is denoted as a B. Please tell me how many branches are there? 1,
5, sir.
2, 3, 4, 5. Very good. Now, can you tell me how many simple nodes? Simple node ante entama only how many branches should be connected at a particular point?
Less than 2 or more.
Two kada? Simple node. 2. This voltage source is connected at A, and AF is connected at this particular node. This is one simple node. Next, simple nodes only, and this is also simple node. So N1 and N2. N1 and N2 are the simple nodes. Next, can you tell me where is the principal node? What do you mean by principal node?
At point B.
Very good. At point B, let us say N3. So principal node is N3. N3 is the principal node. And one more thing is that this element and this element and this element. If there is no element means this is a wire and this is also a wire. All these wires are connected. So combinedly we can say this is a one node. No element is there. So commonly we can say this is one node. And this is connected here, and this is connected here, and this is connected here. So this is also come under one node only, that is known as a principal node. While we are solving the problem, I will tell another principal node is another one. Okay, na? Now, so this is about a node, branch and node. If you come to the loop, see, if you take this one, A, B, E, F, and A, I'm starting here, I'm traveling from A to R through R1, B, R2, and E, and again E, F, and again A. So which can form a closed path. This is known as a loop. Okay, na? And here also, if I start from here, I can travel like this, and again I can reach to the same point. This is another loop. Okay, these are the two loops, and one more loop is there. Can anybody guess another loop here? Any possible closed path? Can anybody guess another loop in this circuit, electrical circuit? This is one loop. This is one closed. This is another closed path to start from BC. Let me write here. A, B, E, F, and A. This is one loop. Next loop is B, C, D, E, and again B. This is second loop. Second loop. Third loop is to start from A to B, and B to C, and D, E, F, and again A. Are you getting me? This is also a loop, third loop. A, B, C, D, E, F, and A. That means all possible closed paths are known as a loops. That is the definition of the loop here. A loop is any closed path in a circuit. Loop is any closed path in a circuit. Okay, which is denoted as a L. Node is represented as a N. Branch is B. Now, a network with a branch B and N nodes and L independent loops will satisfy the fundamental theorem of network topology, which is equal to B equal to branch B equal to L plus N minus 1. So the branches in a particular circuit must be equal to loop plus N minus 1. Let us check these things in this. That is the formula. Branch B equal to loop plus N minus 1. How many loops are there, Amma? How many loops are there? L equal to, in the circuit, how many loops are there? Possible loops. 3. So 3 loops. How many nodes are there? All nodes, principal nodes and simple nodes. One simple node, another simple node, another principal. 3. This is one node. This can be treated as, I think, ground node. 1 and 1 and 1. 1, 2, 3, 4, 5. Okay. So simple node and principal node combined it is a 3 minus 1. And thus number 6 minus 1, which is equal to 5. So any branches would make count chain. Branch 1, 2, 3, 4, and 5. Okay. So according to this formula, according to network topology, the branches, sometimes they may ask 2 marks question. They will give a circuit. They will do circuit. You have to identify the loops and the nodes, and if you subtract from this minus, you will get total number of branches in a particular circuit. So if you know about these loops, nodes, and branches. Now we can define a KCL, KVL, and Ohm's law, the basic ones. Class is up to 11:40, Amma. So any doubts in these loops, branch, and nodes? Nineteen 122. 122. 122. It's not responding. Nineteen 125. 125.
Yes, sir.
Yeah, please can you define loop, Amma?
Yes, sir. It is a closed path, sir.
It is any possible closed path in a circuit. Any possible, Amma. Okay.
Yes, sir.
Node. Can you define a node? Branch.
Yes, sir. Node is a point of connection, sir.
Very good. Point of connection of any branches.
Any branches, sir. Branch with a
Branch
single
means-
element, sir. It may be a voltage
Very good.
resistor, sir.
Very good. Very good. What is your name?
Mohanadipti, sir.
Dipti. Very nice. Very good. Atlane follow only. Now next one is resistance. After completion of resistance, inductor resistance, we'll go for these laws. Let me finish this resistance. Later I will stop here. See, resistance is a property of a material. It is a property of material, or let us take a conductor. Property of any material or conductor, which is a restriction of current flow, or which opposes a flow of what is that property? Which opposes the flow of electrons. It is just like a friction. If you take a mechanical one, it is a friction which opposes, and a bus is moving on a particular road, there is a friction which opposes. Or if any high amount of the wind is flowing, it will opposes the motion of which one, a bus or car. Likewise, if you take a copper conductor, there are so many electrons at it. There are so many electrons. And if you apply a battery with the help of the wires, a 5 volts battery, then these electrons are moving in a loop. Now you can understand, this is called a loop. In a loop. While these electrons are traveling in a loop, due to this property of the material, some opposition when these electrons are flowing, inside this conductor, wire and this conductor, some opposition is taking place due to that property of a material. That property which opposes the flow of electrons or charges is known as a resistance. Okay, so increasing resistance will reduce the flow of current. I will discuss this point after discussing the Ohm's law here. And here, this is a voltage. The flow of electrons is nothing but a current I. And the property of this material which opposes the flow of electrons is known as a resistance. And that property can be modeled as a resistor, which is symbolically represented as this. This is the what? Symbolic representation of a resistor, and which is denoted by R. R is denoted for resistance. Okay, so finally, the conductor property can be modeled as a resistance R. This is a voltage V, plus and minus, current I is flowing. Current I is flowing. This is known as a electrical circuit, we know. So what do you mean by resistance here? It is a restriction or opposition to the current flow. Current is what? The flow of electrons. Okay. Now, electrical resistance is measured in ohms. In the name of scientist, the units for the resistance is ohms. Okay. And they are abbreviated by the letter R. The resistance is represented as R, and the symbolic representation is units for ohm. Like if you take a property of resistance as a resistor, that resistance equal to 5. We can write 5 ohms or 5 like this symbol. This is omega symbol. You can write 5 ohm or this, like 1 ampere current, 5 volts. You can write 5 ohms. Next, another definition here, which opposes the flow of current or flow of electrons. Units are ohms, and it is measured by ohm meter, and the device which is used to measure the resistance is ohm meter. Current is measured by ammeter, and voltage is measured by voltmeter, and resistance is measured by ohm meter and connected across it. Suppose I don't know the resistance of a particular material, then I can connect a ohm meter between these terminals A and B, which will measure the resistance. The reading will shown here, like 10 ohms, 5 ohms, like that. Based on the property of the material, that will be measured by the ohm meter. And it also depends upon the type of the material, and the area of material, and the length of the material also, because R equal to design formula rho L by A, where L is the length of the material and A is the cross-sectional area, rho is the resistivity, specific resistivity. It depends on these particular parameters. So it depends on the material, that is rho. Rho is different for different materials, and area and length. And it produces heat when the current flow through it. I will give you a best example for this. Heater. Might have seen the heater like this. And there is a wire which is used to connect to the switchboard. Yeah, it is a material, right? It is a what? A material which is having a property of resistance. When you connect a heater to a switchboard, the current is flowing through this element, this material, then heat will be developed. The heat will be developed. So the best example to understand this point is, it produces a heat, the material, the property of a resistor. is produce a heat when current is flow through it. Fixed and variable resistors are present. You can change the resistance. See here. Resistivity. I already said that R equal to rho L by A. See, if you take a copper conductor, this is a copper conductor. The length of the copper conductor is L. Length of the copper conductor is L. And this is a cross-sectional area. What do you mean by cross-sectional area? If you cut that conductor, you can see this cross-section. Imagine three-dimensional. This is a cross-sectional area A. And material with a resistivity. This is specific resistivity. The equivalent of a conductor can be represented as this symbolic representation of the R. If you apply a voltage, current will flow through this. Now, the resistivity of the common materials like this here, material, the silver material, copper material, aluminum, gold, all these are material. Each material has having its specific resistivity. And 1.64 into 10 to the power of minus 8 ohm meter. Resistivity units are ohm meter. And it is used as a conductor. Copper, this specific resistivity is this much. Is used as a conductor. Aluminum is used as a gold is used as a conductor. Due to the high cost, we are not using gold as a conductor. Copper or aluminum. Okay. Now carbon, germanium, silicon, these are common under semiconductors. Paper, mica, glass, and Teflon, these are common under insulators. Because of the resistance, if you observe the resistance of the insulator, చూడండి ఎంత resistance చూడండి. This much of resistance is there, very, very high resistance. 10 to the power of 10 ohm meter per meter, this much of resistance. Okay, there is a high amount of opposition is there, so that current will not flow, so that those are known as the insulators. Okay, so this is the symbolic representation of a resistance, and this is a resistor. So with this we finished the resistance also. This is the symbolic representation of resistance. It is measured in ohm. Okay, it is a property of material which opposes the flow of electrons. So, in concluding here, today we discussed about current, the flow of electrons, which is denoted as a current I. Units are amperes. Here. Next, we discussed about the voltage. V. Units are volts. How to define a voltage? Work around to move a charge. Mathematical expression is I equal to dq by dt, and mathematical expression is V, work done per charge. Next, we discussed about the power, P, time rate of energy, that is dW by dt. Units are watts. Later, we discussed about node, branch, loop. Node is an elemental connection, and branch is an element. Node is an interconnection of the branches. Loop is a possible combination of closed path in a circuit. Later we discussed about the resistance. Okay, it is a property of a material which opposes the flow of electrons, and it is measured in ohms. Symbolic representation is this, and a letter R is used to represent the resistance of a particular element. So these are the specific resistances. Sometimes they will give length of the conductor and area of the conductor, and you want to calculate R value for a particular copper or silver. Then you have to substitute this value, 1.72 into 10 to the power of minus 8. So these are the basic things which are use it to understand the Ohm's law. Once if you thorough with these definitions and these concepts, Ohm's law is very simple. So in next class, we'll discuss about the Ohm's law, KCL and KVL, Kirchhoff current law and Kirchhoff voltage law, and we will do some basic problems on this.